Hello everyone, this is a series of lessons about Introduction to Programming. In these lessons, we will discuss basic building blocks of structured programming and its uses. From the language point of view, we will be using procedural part of C++ language. So let's start with what is programming. If we see typical definition of programming, it is precise sequence of steps to solve a particular problem. So in a generic way, when we say that we have a program, it means that we know all the activities in an order which we need to perform so that we can solve a problem. So let's take an example. So if we want to go for a picnic, we usually make a plan for that, including what all activities we will do. This helps our trip to be smooth and well organized. So this is nothing but a program for a picnic trip. And similarly, there are lots of such programs in our day-to-day life. Now if we talk in terms of computer, programming a computer means telling it to do something. So the only difference is that computers do exactly what we tell them to do, no more, no less. And this is unlike human beings, as we can infer many things which are not told to us. So for being a good programmer, we should focus on few very important points. And firstly, as we discussed, that computers are somewhat dumb, so we have to pay attention to the details while writing the set of activities that we want the computer to do. Next, as a programmer, we have to think about a good user interface, which should be self-explanatory. We must not assume that the users of our program have a very good understanding about computers. Now let's discuss about software and its categories. So the programs that we write are nothing but software. And if we see our computer, there is CPU, and inside that we have processor, RAM, motherboard, and many such things. All these are hardware parts of our computer. However, we cannot use this hardware directly. To interact with this machine, we have to write programs, that is software, which are set of steps or instructions, or the activities which we discussed in the previous slide. So these instructions are then given to this hardware part, which performs this step by step and hence completes our required task. So we can categorize these softwares into two parts. One is system software and other is application software. Now, as the name suggests, system softwares are there for the system itself, and its main motive is to control the computer. It basically communicates with different hardware parts such as keyboard, mouse, network card, and so on, and helps those to perform their operations. As shown in this figure, we have operating system, device drivers, and other utility programs that fall under this category. So it is the operating system which manages all the other programs in the computer. On the other hand, device drivers are software programs which makes external devices such as mouse and keyboard to communicate with the computer. Then we have utility programs which perform specific tasks usually related to resource management. Apart from these, all the other software that we use, such as Microsoft Word or any accounting system or any computer game, which are designed for end users and not for the computer, and that is not to control the computer itself, comes under the category of application software. So of course, in these lessons we will be writing programs which are application softwares. Let's see how C and C++ languages have evolved and what were the other languages used before C. So in early 60s, there were few programming languages such as Fortran, BCPL, which is Basic Combined Programming Language, and Pascal. But each of these languages were specialized. For example, Fortran or formula translation was used just for scientific processing. BCPL was used for writing operating system and compilers. Pascal was used for general processing, but there were few issues in that as well, like it did not support modular approach. So in Pascal, everything is simply a big chunk of program. Then in 1970, BCPL inspired Ken Thompson to make another language called B, which took all good ideas from BCPL, but syntax was similar to that of Fortran. All these languages were typeless languages except Pascal, that is, every data item is of one word in the memory. This created problems for treating data as whole numbers or real numbers. Then finally in 1972, Dennis Ritchie created C language in Bell Laboratories. So he took good idea from B and Pascal along with his own ideas to create the most famous language till date, which is C. Then later in 1979, C++ was developed. So it was not the replacement for C. In fact, it was an extension by adding object-oriented features. So we will be dealing with C and C++ in these lessons. Now as a programmer, when we write programs, multiple steps are involved, starting from writing the program in a text file, then compiling and finally running it. For performing all these activities, different tools are required. Let's discuss each of these. First of all, we need a tool for writing the code. This is editor like Notepad and any other simple text editor. Now as we know, computers only understand zeros and ones, but we write our code using words and alphabets from English language. So for converting our code into computer understandable code, another tool is required, which could be a compiler or an interpreter. In case of C or C++, compilers are used, which simply converts the complete C code into the machine code at once. Another very important tool is a debugger through which we can debug our code. Using this we can stop execution of program at any point and then can check values of different variables. We will see how to work with this later. Then linkers are required, as most of the time we are using some different functions and routines which are already present in different files. So linkers basically get executable code for all those functions and include in our current program. And finally, once we have complete executable code, we need another process, which is loader. This loads our program into memory, that is RAM, and instructs the processor to start execution of program from the first instruction. As we will see, starting point of every C program is the main function. By seeing all these steps, it appears a bit complex that to run a program we have to use so many tools. However, there are lots of IDEs that in which all these tools are integrated, and using the same window we can perform all these steps. So let's see what an IDE is. So IDE stands for Integrated Development Environment, which means that we are provided with an environment in which all the tools required, starting from editor to loader, to develop a software in a particular language are integrated. And here we are using Dev C++, which is a free IDE, and this is the link from where we can download its executable file. Later we can run this executable and perform the installation steps. Now let me open the IDE, and this is how it looks like. So this is a simple tip of how to use this IDE effectively. So let me close this. And the first tool that we discussed was an editor. So go to File, New, and from here we can create a new source file. And this is the window from where we can write our code and then we can save it. So this is our editor window. Then after writing the program, the next step was to compile it. So the next tool is compiler. So you can go to execute, and here is the option for compiling our program. Note there is a window here where the error and warning messages will appear if occurs during the compilation process. So if the compilation is successful, the last step is to execute our program. So again we can go to this execute, and there is an option for running the program. So as you can see that all the tools that we discussed in previous slide are integrated here in this IDE. Let's see a sample program to have a look how all these things work exactly. For now I am just writing the program, its explanation we will see later. Now as we are writing programs in C++, all the files will be saved with .cpp extension. So first of all let me save this file. So go to File and click on Save As. So I am saving my files in D directory. So here I'm creating a new folder, say my programs, and inside this we will be creating all the programs. So for now we are just creating a simple program which simply displays a welcome message on the screen. So let me give it a name, say welcome.cpp. so write welcome and click on save. So as you can see that welcome.cpp file is created for us. So let's write the code. Hash include iostream using namespace std, and this is our main method. That's it. Now save the file, go to file and click on save. Next step is the compilation process. So go to execute and click on compile. So this will compile our program, and as you can see that there are no errors, no warnings in this. So close this. Finally we can go to execute and click on run, and as you can see that the message is displayed here, welcome to C++. Let's close this. Now let's try to understand this program. The first thing is hash include, and this is a preprocessor directive. This is not exactly the part of our program, but it tells the compiler to include contents of a file in our current program. In this case the file is iostream, and the contents are added in the executable code. Then this iostream is name of the library file which facilitates all input and output streams. Basically this file includes standard pre-written code which helps in data transfer. For example, displaying contents on the screen and reading contents from the keyboard. The next line is this using namespace std. Now all the classes, functions, objects which are used in standard library of C++ are defined within a special namespace known as the standard namespace, and it is designated as std. So we will discuss this in details later, but for now, for understanding, as we create various folders for storing related files, such as we create videos folder in which we put all the video files, and we usually create music folder for storing all the mp3 files. Similarly in C++, namespaces are used to keep related code together. This helps in modularity and encapsulation, and once a namespace is defined, we can access its members through the namespace name only. So now here we are using iostream standard file, and this is there in the std namespace. So in order to access the functions and objects of iostream, we have to use its namespace, which is std. One of the iostream object is cout, which we have used in this program. Next is main function. Every C program must have a main method, and this is the starting point of our program. When we execute or run our code, the very first instruction to the processor is to start from this main function, and every function must have these parentheses, and these may or may not be empty. Then there is a curly bracket, and for every open brace we have a closing brace, and this is the closing brace. These braces helps us to group together pieces of program, as in this case body of our main method is enclosed within these braces. The next line, which is this cout, is what our complete program does, that is printing this text on the screen. Cout is known as output stream, and we will discuss about streams later in greater details, which are used for data transfer. Here cout is a stream which takes data from computer and sends it to the output. For example, the output we have is screen of our monitor. Then these double arrows indicates the direction of data. and here it is towards cout. So whatever is written after these arrows within quotation marks will be sent to the cout, and cout will display that on the screen. And the text between the double quotes, these are character string. Last thing to note is this semicolon. In C++, every statement ends with a semicolon. So this indicates the end of a statement. If we miss this, compiler will not compile our program and will give some syntax error. So that's it in this lesson. In next lesson we will discuss about variables, data types, and we'll write few more programs as well. So thanks a lot for watching.